Let's look at a classic rate problem that involves the fundamental theorem of calculus, shall we? So here we have the tide removes sand from Sandy Point Beach at a rate modeled by the function r given by this function. You know, I see the word rate right away. I want to circle that. And this is rate removing. This is a good thing to do whenever you have a function. Jot down its a rate, jot down what it's a rate of so that you can keep track. A pumping station adds sand to the beach at a rate modeled by function s. Okay, so this is a rate at which I'm adding sand. Very important to keep track of that. Okay, both r of t and s of t have units of cubic yards per hour. There's your rate. And t is measured in hours. Here's my restricted domain. And here is my initial condition. Very important. At time t equals 0, the beach contains 2,500 cubic yards of sand. Okay? That's my initial condition. That's going to be important as I go. All right, so here we have our first mission, should we choose to accept it. Write an integral function that would determine the total amount of sand that is on the beach at any time x. Okay, so to get the total amount of sand, I have to figure out how much sand I started with at the beginning of the story, which is 2,500 cubic yards. And then how much sand was added and how much sand was removed over x hours. Well, these functions don't tell me the amount of sand removed and added, but they give me the rates. So I'm going to take the integral of these rates, and that will give me the amount of sand that is accumulated over x hours. Are you with me? So let's go ahead and do A here. Write an integral function that would determine the total amount of sand that is on the beach at any time x. All right. I'm in the mood for not red. Okay, so the amount of sand. You know, let's just define A of t. Let A of t equal the amount of sand at time t. Okay? So if we have that all set, A of t is going to equal the amount of sand I start with, 2,500 cubic feet, plus the amount of sand I've accumulated. That's going to be the integral from 0 to x hours of the amount of sand I've accumulated. Well, I have added sand at a rate of s of t. I removed sand at a rate of r of t. So it's going to be the integral from 0 to x of s of t, I'm in red for some reason, minus r of t dt. There's my integral. There's my integral. The amount of sand I have at time t is 25, whoops, let's say the amount of sand I have at time x, that's more accurate, is my 2,500 plus from the integral from 0 to x of the rate at which it was added minus the rate at which sand was removed. There it is. There's my integral function. Are we good with that? Okay, B is just asking me now to use that integral. How much sand is on the beach at time 6? You may use your calculator, it says, but let's show how we are setting this up. Okay, so B, the amount of sand I'm going to have at 6 hours will be my starting value, the amount of sand I have at time 0. Then from 0 to 6 of s of t minus r of t, all with respect to t. All right? Now, let's put that in your calculator. Whenever you're doing a problem like this, especially a multi-step problem, I strongly recommend you go ahead and put one of your functions in y1, put the other function in y2, and then you can use the functions over and over again. So I have this ready to go. So there's my first function, there's my second function. Whenever you're doing a problem on the graphing calculator, make sure that your window matches the domain that they gave. Note, they gave me a domain from 0 to 6 hours at the beginning of the problem, so that's my x-min and my x-max. I'm just kind of choosing a y that I hope works. Yeah, this is looking pretty good. So here we go. The amount of sand at 6 hours is my 2,500, what I started with, plus the integral, alpha window, choice 4 is the integral, from 0 to 6, since I'm seeing how much sand accumulated over those 6 hours. We decided that y2 was the function I want, so alpha trace, you can tell the calculator you want the function in y2, minus alpha trace y1, and I'm taking the integral with respect to x. Drum roll, please. And we have 2,493.27667 cubic yards of sand equals, and let's leave always 3 digits, 2,493.277. Did they ask for units? They didn't, so I don't have to put it, but if they did, we would say cubic yards. And you physics people, it's always good to leave units. Okay. So now, C, at time 4, is the amount of sand on the beach increasing or decreasing? So, of course, whenever you're talking about if a function is increasing or decreasing, you want to know about the slope of that function, right? Or the rate of the function, or the derivative of that function, right? So, is the amount of sand on the beach increasing or decreasing? Well, we could take the derivative of this function, right? The derivative of a of x, well, this is going to go away, right? Derivative of a of x is going to be 0 plus the derivative of this integral. Oh, this is so interesting. The derivative of a of x is just going to be, because of the Fundamental Theorem of Calculus, part 2, the derivative of an integral, of course, they undo each other. That x goes on in there, so it's s of x minus r of x. And then I stop and think about it and think, well, of course, I didn't even have to take the derivative. I could have just thought, wait a minute. S of x is the rate at which sand is being added to the beach. R of x is the rate at which sand is being removed. I could have just looked at the rates and thought, okay, which is bigger, S of x or R of x? At the moment, 4 hours. So yeah, I basically now just want to know, well, S of 4, what's the rate at which sand is being added to the beach at the 4th hour? And what's the rate at which sand is being removed? I want to know if that's going to be a positive number or a negative number. Let's ask our calculator. And this is when it's so handy to have those graphs already in the y equals. So my y1 was removing the sand. So let me show you a cool trick. You could do this a couple of ways, but I can do my alpha trace y1 parentheses 4 da, 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 and it gives me the y value of that function. Let's do that with y2. So alpha trace y2 of 4. Okay, you know, that is so annoying when calculators do that. But, let's see. For some reason it wanted to do that. Is it going to continue to do that here? Okay, so 4.615. Okay, so this is so interesting, isn't it? So basically, let's go back to my page. S of 4 was about 4.6154. R of 4 was about 6.5241. Well, I don't even have to subtract them to know I'm going to get something negative, right? I'm going to get something negative here. And if I'm getting something negative, that means my function showing the amount has a negative slope. So the amount of sand at 4 hours, the amount of sand on the beach is decreasing since S of 4 minus R of 4 is negative. Right? And we should actually get our value here, 1.908. Okay? So, if our rate is negative, our function, expressing the amount of sand, is decreasing. And therefore the amount of sand is decreasing at the 4th hour. I hope that was helpful.